Hello everyone. So today's our topic is recovery concepts in DBMS. So here in this we should observe the first thing is recovery and atomicity. So here already we very well know the atomicity is nothing but execution of the transaction entirely. Either it can be completed successfully or it can be completed unsuccessfully. So whenever the transaction is perfectly completed with the commit or abort operation means, so here in this case how you can recover the transactions. So let us here we are already discussed the mechanism here. So let us take it with one example. The TI transaction is there and one more is TJ transaction is there. It transfers the funds from 50 rupees from account A to account B. So likewise we are going to define whether during this transmission of the amount from one data item to another data item, so any transaction failure occurs, then how you can recover those. So let us see with an example here. So how you can recover these failures. So how you can instead of any type of failure occurs, then how you can define the atomicity properties. How you can ensure that the system which can execute properly and all the database modifications that can be loaded to the stable storage. Means here the stable storage means the non-volatile memory. Here it is going to be calling it as the disk here. So what are the approaches we are defined for ensuring the atomicity property? So the first thing is here you can ensure the property of atomicity. So here in this case you are observing the two mechanisms. So we are already discussed in our previous video. The first mechanism is a log based recovery and second mechanism is here shadow paging. So move to log based recovery. So what is a log here? The log is nothing but here it is a file. It is nothing but a log file. You can define the collection of set of log records. So here in this case log records means whenever in the particular schedule any transaction is going to be started, whether T1 start, here we are going to write T1 start. So likewise if it is a TI transaction, TI start. So if it is executing read operation, then TI X, then whatever the value we are going to perform. So if it is a read value, only one value is going to be there. If it is the write value, two values are there. So TI is a transaction identifier, X is the data item, and V1 is the old value, and V2 is the updated value, new value. So likewise it is, if two values are there in a particular log file, in a particular log record, then we are going to be say this is executing the write operation, write on X. So likewise we should keep all the log records. So nothing but TI start, TI reads, TI writes, TI commit, TI abort, TI end. So likewise from start to end, we are going to write the entire status of the each and every log record in a particular log file. So whenever any transaction failure occurs, then every status of the transaction is going to be recorded in the log file. So by using this, you can identify whether it executes read or whether it executes write or whether it is performed the committed operation or not yet committed, or it is in partially committed state. So you can observe each and everything. So in order to execute the log file, we are having the two type of mechanisms. One mechanism is defer database modification, and the before mechanism here we are going to be calling it as immediate database modification. So observe this defer database modification. So nothing but the definition, exact definition of defer database modification scheme, nothing but it records all modifications to the log, nothing but it everything that it starts, read, write, commit, everything is going to be stored onto the log file. So for this purpose it differs all the writes to after partially committed, nothing but if it is executing, whether the transaction is in active state or whether it is performing read or write, whether it is partially committed or committed. So if it is partially committed means in the buffer the data is going to be updated, but it is not yet updated on the disk. So likewise you are going to, whether if it is updated or not, you have to perfectly check it out. So by using this, by observing the log files, so nothing but TI starts, write operation, commit operation. So likewise we are going to each and everything you are going to be deferred. You are going to be write on the log file. Based upon the log file, you have to execute the two functions. The first function which you are going to be calling it as here undo, and the second function which you are going to be calling it as here redo. So likewise, when we have to undo and when we have to redo. So here, in order to undo and redo, we have to check it out. The TI starts and TI commits. Nothing but the initial statement is TI start and the final statement is TI commit. So before that, in between the start and commit, it executes the read operation and write operation. So like that, it may execute. So in this case, you are going to observe when the transaction failures. So whether before commit or after commit. So before commit is nothing but whether it executes the partially committed state or not, we can observe. If it is partially committed state, means the changes are done in the buffer but not in the disk. If after the commit, means we can observe the changes are done in the disk. So if it is done in the disk, means there is no recovery. So nothing but we can't recover. You can go for the next transaction. So why? Because the changes which are going to be already done in the disk. So likewise, we have to update with the new value. If it is before the commit, means it can be stored in the buffer only. So it is not yet committed. So its changes are not updated to the disk. So likewise, we have to undo, means we have to restore the value with the old value. So likewise, we can execute the two functions. One is undo and redo. So the simple best example is, if it is before commit, means you can execute undo, means store with the old value. If it after the commit, means you can store with the new value. You can execute the redo of the transaction. So let us, we are already defined the example, one example, that T0 and T1 is a transaction. Here T0 transaction, what it is performing, transferring the funds of 50 rupees from account A to account B. So you are going to perform the read operation of A, and A 50 rupees will be deducted from A, and you have to perform the write operation, and these 50 rupees will be added to the account B. So likewise, we can execute the first transaction. And what executes the T1 transaction? Just only transferring the deducting or withdrawing the amount 100 rupees from account C. Simply you have to write read C and C deducting the amount, and you are going to execute the write operation. So likewise, you are going to execute. And here in this case, observe the three situations here. The first situation is whatever the initial values of A are 1000 and initial value of B is 2000. So after transferring the fund, A value will be 950 and B value account will be added, so it will be 2050. Then after that, so you can observe the three situations here. In these three instances of time, the transaction failures, means after execution, after write of B, then there is no commit, then the transaction T0 transaction failures. Then how you can recover the T0 transaction? In the second situation, the T0 commit is executed and T1 transferring the funds, so it executes the 600, but T1 is not yet committed. So in this case, T1 after the transaction, T1 after then failure occurs. Then how you can recover? So here in this case also, T0, T1 both are committed. After commit of the two transactions, if it is failure occurs, how you can recover? So in these three situations, we are going to execute the what operation here? So nothing but here, the first situation means there is no commit. So if there is no commit, means you can't do anything. So nothing but here there is no redo action is going to be performed, means both the values which are going to be stored with the initial values. So so it means no action can be performed here, no redo action can be performed here. So here in this case, deferred database modification, simply you can observe only one operation, that is redo. So you can simply redo. So after commit means you can redo. So before commit means you can't redo. So simply you can execute only one operation, that what we call it as redo. So here in this case, the first situation, it is not yet committed. So you cannot perform redo action. And second situation, the T0 is committed. So then which transaction you have to, after T0 commit, the transaction failures, means after committed, so you are going to redo the T0 transaction. So for this purpose, you can redo the T0. Why? Because T0 commit is present in the particular execution of the transaction. Then T1, after T1 there is no commit, so you can't redo any operation. So then there is no redo for T1. So here in this case, that is second situation. First situation is no commit, so no redo operation. Second situation is T0 is commit, so you are going to redo T0 transaction, and the T1 after, then there is no commit, so you are going to don't perform any redo action here. And the third situation, a T0 commit is there and T1 commit is there. So in this situation, you are going to execute both redo operations. So redo of T0 and redo of T1. So likewise, you are going to execute the default database modification. Then coming to immediate database modification, the same action is going to be executed here also. But here you can observe the uncommitted transaction and you can observe the committed transaction. So likewise, in the previous case, default database modifications, only redo action is going to be performed. Before commit means no redo, after commit means the redo action is going to be performed. So here in this immediate database modification, you can immediately you can execute the redo operation and undo operation. So here in the situation, the same example, previous example you are carried here. Let us observe T0 transaction, T1 transaction started and committed. So both the commit operation is going to be executed. Then what we have to execute here? So here in this case, you can execute the two operations. First one is undo and second one is redo. So undo means here, this undo transaction is not executed in the deferred. But here we are going to observe the uncommitted and committed transaction. So likewise, we are indicating the undo and redo. So undo means here restoring the old value and redo means restoring the new value. So that what we are going to be exactly performed. So the same transaction, you can observe the start transaction, commit transaction, the same example carries here. So here in this case, what we have to do for the first thing, the 1950, 2250, here there is no commit. Generally, there is no commit means what we have to do? You have to undo. So you have to undo T0 transaction. So undo means you have to restore with which value? Old value. So the for the A, what is the initial value? Old value, that is 1000. So you have to be updated with 1000. And go to the second situation. Here T0 commit and T1 is not yet committed. So T0 commit means commit statement is there. Then what we have to do? Redo of T0 transaction. So you are going to execute the redo of T0 transaction. Then T1 C, then T1 after, then there is no commit. There is no commit means you have to execute the undo operation. So you are going to execute the undo of T1. So you are going to execute redo of T0, undo of T1. A redo of T0 means restored with the new value. What is the new value of T0? The new value of T0 is 2050. So it can be restored with 250. And what is the value of T1? T1 value is, initial value is 700. So likewise, we have to undo 700. So for this purpose, we are going to be setting the value of 700. So likewise, and move to the next case, T0 and T1 transaction here. So here in this case, T0 is committed and T1 is committed. So for in both the situations, your write is updated to the disk. So it is properly modified on the disk. So what we have to do? You can execute redo of T0 and redo of T1. Redo of T0 means both the values are updated values. Updated value means for A 950, for B 2050. So here for C 600. So let us move to this and redo of T0 and redo of T1. For A and B values are restored with the new values, updated values. Similarly, the C value is also updated to 600. So likewise, we are going to execute the concept of atomicity. So here in this case, you can observe one more point, that is what we have to be done exactly for the concept of checkpoints. So here in this case, you may very well know, deferred means here moving the redo action only without performing uncommitted transaction. Nothing but uncommitted means you can't do any action here. Simply no redo action is going to be performed. Immediate database modification means you can execute both undo and redo. So likewise, we may execute the concept of undo and redo. So hope you understood. For further next concept of checkpoint, we will see in the next video. Thank you.